now we will go for multiple linear regression. Like I said, multiple linear regression is here we have only one data, one dependent variable and one independent variable. So the dependent variable will be one, but the independent variable may be as many as possible, as many as you can. You can keep as many as you want. So there will be some applications like that also, where one variable cannot predict the complete model. So, for example, house pricing also, one variable cannot predict the price of the house. There will be lots of things. So, in that cases, we will definitely go for multiple linear regression. So, in this case, enough because years of experience and salary, definitely simple linear regression will be good. It will work fine. But here another case I'm taking, so that is startup company. Okay, I'm just opening that file. So whenever you open the Google column, just connect it with your server. So now it is connected with the server. So you can see connected to Python 3 Google Compute Engine backend. So upload the startups. So this is another scenario. So yeah, investor is coming and he is asking engineer, okay, to find out that startup, which to find out the company to invest. So there is lots of company. The investor will invest on it. So which company they want to invest, they can easily find with the help of data science and algorithm. So this is some of the data set. So in a financial year, top 50 startup companies details are here in this data. Top 50 companies. Okay. So the last column is the profit column. So that is your dependent variable. The profit is the dependent variable because your investor will interested in the profit of the profit. So this is the dependent variable. But the profit is not. It depends on many scenarios. One is R&D spend, administration, marketing spend, as well as the location, where it is located, where the company is located. So the investor is not only interested in the profit, is also interested in how the company is running, whether they spend more on the marketing and they get the profit, or they're spending more on the R&D to get the profit. Okay. Whether their administration is fine or so, maybe the administration, because your administration cost should be less than the R&D. Okay. So there is lots of criteria behind it. Okay. Not only the investor needs to know the all the scenarios. Okay. The location, the spend, marketing spend, administration, as well as R&D. So the profit is based on what? Based on. So for that we need a model. So only with this linear regression model only we can able to find out the relationship between the dependent variables. Okay. So we need to find what is the relationship between this to get the profit. So that is the main. The same concept. Okay. So that's why I created this template. If you can use this template for any algorithms. So at the end of the session, I will give 2 more data set. You can work with the same template. So what is the template? Uh, since I have already thought how to do that, and do it. Okay, this column putting that just delete it because we need to know what are the steps of this one. Otherwise, you'll get confused. Okay. So first encoding categorical data. So only that and the data chain and the full linear regression of the training set and the training also same and finally predicting the test results. So a little bit different will be difference will be there. I will tell you what is that. So again, so three library functions. Like I said, NumPy is for and plotting the data is for and importing the data set. Now the next step is importing the data set. So you can use the same thing. Here you can see the ilog function is a little bit different compared to here also it is same. Okay, anyway, I'm going to tell you how we can use that function. So now just times x and I'm going to see what is the value of x. So you can see in a array format because dot value converts the table to array. Okay, in the array format you will have because in the sample data you will have 4 independent variables. Independent variables are there, right? So we'll see what is that. So it is R&D. First column is R&D. Second is administration. Third is the marketing spend, and fourth is the place. So that is the state. So except the last column. So this is the column part. Except the last column, all the columns as there in the X. And Y as the last column alone. Okay. So if you want to check, you can check it. No problem. Now I want only okay. So I want only focus on the R&D. Like simple. Okay. So R&D, where is R&D? R&D is in the first column, right? So that means 0. So always the will start 1, 2, 3. Okay. So if I put 0 here, let's see what is the change just happening. If I put 0 here, again you have the x. I'm going to print x. Okay. What is the value of x? So yes, the values are there. If you want to put 1, you will get only administration values. If you want to put 2, you will get only marketing. Because, so that is the column. All the rows will take, but the column is based on this value. I want the columns between 1 and 2. That means alone I want means I can do 1 into 2 and then run it. You can see I will have, so okay. So what I mean is 1 and 2. So between I have to give more spaces, 1 and 3. If I give 1 and 3, what that means the last it will not take. Okay, so 0, 1, 2, 3. This is the third column. So what I given is 1, 2, 3 means it will take administration column as well as marketing. The 3 it will not take. The last column it will not take. It except the 3 and except the 3. That means administration and marketing there. So you can have the values. You can separate the values and you can. So now I am interested in all the values. So that's what I am giving -1. That is except the last one. All the things I am taking. So are you able to understand this little ilog functions? Because it will be maybe you may interest in some other data set if you are taking this. You are may interested in some other data. So that means you need to do that. Then the encoding categorical data. So what is this? See, your machine learning algorithms will the numbers. It will okay. So the numbers only it will calculate because it is a mathematical operations. Behind that, it is a mathematical operations. So here that New York, California, these are the characters. So what we need to do is we need to convert this data into numbers. Then only you can be able to use that in the machine learning algorithm. So for that purpose only, we are using this column transformer. Okay, compose column transformer. So it will transform one column into numbers. So we call it as categorical data. These are categorical data. You have 3 cities here, New York, California, and Florida. So what we are going to do is we are going to do some pre-processing. That means we are using one-hot encoder. So you can, you know what is encoding? Encoding means converting it into numbers, right? Data into numbers. So we are using column transformer. We are taking one column transformer and we are keeping that in the variable CT. Transformers. So these are the functions, and we are going to encode the values of this New York, California. We are using one encoder algorithm. Here you can see 3. Why I am giving 3? So that is very important because here I have 3 categories: New York, California, and Florida. So that's why I'm giving 3. If you have 2 categories, then you can give 2. If you have 4 categories, then you can give. Okay. And then reminder is pass through. Okay. So after that, so this is your one not encoder function. After that, I'm going to train this CT for the values of X. For all the values of X. What is the values of X? These are the values of X. All the columns. Okay. For all the values of X, I'm going to train. Fit means train, right? I'm going to train this column, the particular column. That means the New York, California column for all the values of X. And I'm storing that in the X. Okay. So I'm just running it. So it is correct. And just see what is happening after the encoding. Export of some error. So if you, in case if you are getting some error when you are doing some program and learning some program and all, so easy way to find the error is you can put that, copy that error and put that in the chat. Then it will give you the errors. Okay. Okay. So now, so this is the column transform. It is correct, and we want to see what is the values now. Okay. I'm interested to see after encoding what is the value. So I'm not able to see it. That's the problem. So this issue is not on the code. This issue is due to the of some error. Okay. So I'm not able to visualize the error. I visualize the X value. So I'm interested in that. I want to show you how the code. Okay, I got it. So now you can see after transforming, you can see that encoder. You can see there will be no New York and California like that. Okay. Okay. Here you can see lots of things, but after that you will not have anything. Okay, we will see that. Okay, we will move on. And then splitting the data set into training data set. Okay, so this is the actual thing you should get. After encoding, you will have encoded part 0, 0 is for 0, 0, 1. So that is for Florida. That is for the, so we can see from the data set, that is for Florida. And this is for another one. Okay, 0, 0, 1, 1, 0, 0, 0, 1, 0. So this is the value we'll get. Okay. Next. So now your state has been converted into numbers. So this I already explained. You need to convert the same part of the code only I am copying. Okay. So for training as well as for the test. And we are going to create a model. So this is also same in that. Okay, we are going to train for the sklearn model, import linear regression. Okay, so regression regressor is the variable model variable name, linear regression, and we are fitting the or training the model with X train and Y train. I'm just giving the run. Now your median model will be created. Not convert string to float. There will be some issue over here. Okay, the model is created now. Next is predicting the test result. I'm going to use some comparison over here. So I'll explain this part. Predict. Why predict is the variable. Regression is the model that we are creating, and we are going to predict the values for the test. Test is the x values of 20% of the values in the data set. Okay. And NP is the numpy array. And I'm going to set the print options with the precision 2. That means the values, the test values output will be with the precision of 2 points. That means floating point will be 2. Okay, 2.00 or 2.01 like that. Okay. And then I'm going to print. What I'm going to print it, again, I'm going to compare the two arrays. Concatenate means comparing, joining the two arrays. So what I'm going to join is, I'm going to join dot reshape. Why we are going to use dot reshape is, we are going to convert the single dimensional array. The output of the result is a single dimensional array into column array. Okay. So 2-dimensional one. So that's why we are using reshape. So when you are using reshape, you have to mention how many rows and columns. Okay. So the first part is the row. So how many rows I'm going to take? I'm going to take the rows of y predict. Okay. Based on this predicting result only, I'm going to the length of the row is depends on y predict. Y predict means for X data set, 20% of the values. Okay, there may be 30% you can use, some may be using 40%. So it is based on the X test value. Okay, so that's why I'm taking length of y predict, comma 1. 1 is the single column. After that, y test dot reshape length. Okay, after that, the same length, that is the column rows, and then y. So what is this y test and y predict? Okay, so y test is actual test output in the data set. Y predict means the predicted value from the data set. So I'm going for the test as well as the predicted value. Okay, so you can see from the data set, 20% of this values is used for testing. Okay, so the test value has 20% of this value, as well as the profit. So profit is y. Actually, profit is y. Okay, y test. So for testing, we are called as y test. 20% for y test and 20% for x test. So I'm training after a prediction. There will be some predicted output. I'm comparing the predicted output with the actual data value. Then I can able to understand how much accuracy I am getting from the data set. So for example, here you can see this is the predicted value. Okay, and this is the actual value from the data set here. So you can see it is almost the same. Here is 103015. Here it is 1032. Okay, the prediction is, and here you can see 132. Here it is 144. So actual value is 144, but the predicted is 132. So somewhat less in compared to that. And here 71. Here it is 77. Okay, so this is the prediction of the. So you can see the analysis the model with the help of this also. So since we are using multiple parameters, you will have this regression. Okay, so we have seen simple linear regression as well as multiple linear regression. The only difference is simple linear regression means one independent variable, one dependent variable. And for multiple linear regression, we will use multiple inputs, multiple independent variable and single dependent variable. So you can work with any data sheet now. So